6.3 complex rational expressions. So if you were wondering, the word complex is not really a good sign sometimes in math. These are going to be kind of complicated, which is another kind of similar word to complex. But we can do this. The steps that we want to take, and those steps will probably make more sense after we've done one and not beforehand. Number one, we want to get a common denominator for the numerator. Basically, okay, let me back up. What's going to happen is that we're going to have a big fraction with like little fractions on the top and the bottom. Okay, so our first step is to get a common denominator for the numerator here so that it can be written as one fraction. Then we get a common denominator for the denominator so that it can be written as one fraction. Then we divide those, because if it's a fraction over a fraction, fractions are division, so we can go ahead and divide like what we did in section 6.1, and then we'll like simplify and be done. So here we go, example 1. Keep in mind that this 6 can be written as 6 over 1, this 1 can be written as 1 over 1. Just looking at the top, ignore the bottom for now, we have 6 over 1 plus 3 over x. Our common denominator for that would be x. And to get an x for this first fraction, we would multiply the top and the bottom by x, which means that on top we're going to end up with 6x plus 3. Okay, we need a common denominator of x, so we put an x on top and bottom, and then our numerators come together over our common denominator. Similarly, on the bottom, we need a common denominator again of x, so we times the top and the bottom by x, which just makes it, since it was 1, it makes it x over x. So we combine our numerators, and that gives us x minus 4, and it's over x. So what's happening here is that we have 6x plus 3 over x, and we are dividing it by x minus 4 over x. To divide two fractions, we take the second fraction and flip it, and then make it multiplication instead. Okay, so I took the second fraction and flipped it, so I can cancel these x's out because they're the same, but the other way, those are not the same, so they get written as our answer, 6 plus 3 over x minus 4. Technically, we can factor the top into 3 times 2x plus 1, but since that doesn't cancel out, you wouldn't necessarily have to do it, but it is good to always check and see if what you have cancels out. So this is all going to be pretty much the same, but little things different. So we're going to keep practicing together here. On top, on example 2, we need a common denominator of 4x, because one of our denominators has an x, one has a 4, so we put them together. So for the first fraction, we need to multiply by 4 on the top and the bottom to get 4x for our denominator. For the second one, we need to multiply by x on the top and the bottom to get 4x, which means that our numerator is going to be 4 times 4, which is 16, plus x times x, which is x squared, over something very similar happens here, that on the first one, or the denominator is 4x because we have a 4 and an x, but on this one we times the first fraction by x, the second one by 4, which gives us x squared, and since it's a minus sign, x squared minus 16. So now we're ready to divide, because this is 16 plus x squared over 4x divided by, or if you are savvy enough, instead of writing it as a division problem, just multiply by the fraction on bottom. So that's 4x, the reciprocal of the fraction on bottom, 4x over x squared minus 16. So the 4x and the 4x cancel out, giving us 16 plus x squared over x squared minus 16. Now, if we want to try to factor to see if this simplifies, we can factor the bottom into x plus 4, x minus 4, because we can take the square root of both, and there's a minus in between. But on top, we're stuck leaving this alone. Even if we switch it around and make it x squared plus 16, because the middle is not a minus sign, we cannot do anything with that. Okay, so this would be our answer right here. X squared plus 16 over x plus 4 times x minus 4. Example 3. Now this one is actually, they've helped us out because there's only one fraction on top, which means we don't have to get a common denominator there. So that was nice of them. And then on bottom, we have 1, which we can make be 1 over 1, but we want our common denominator to be x plus 5, so really we're going to turn that 1 into x plus 5 over x plus 5. So that now we have common denominator, because 1 we can turn into anything. 1 can be 5 over 5, it can be 10 over 10, because it just has to be the same on the top and the bottom. So it's x plus 5 plus our other numerator, which is 1, over the denominator, which is x plus 5. So we do need to go ahead and combine 5 and 1 here, so that that's like a plus 6 instead. So that's x plus 6 there. Now let's divide. So we flip the bottom fraction and get x plus 5 on top, x plus 6 on bottom, and see what cancels out the x plus 5s, leaving us with 1 on top and x plus 6 on bottom. Example 4. Like I said, these are all just a little different from each other. So on top here, to get a common denominator, this one's a little more complicated. We need to have x and x plus 4 be in our denominator. So that means our first fraction, to get that, we have to multiply by x on the top and the bottom. On our second fraction, we have to multiply by x plus 4. So, let me just move this over so we have more room to work. Alright, so we have an x on top here minus 1 times x plus 4. So this negative is making that 1 negative. So when we distribute, it's negative x minus 4. That's what's going on the top. On the bottom, all we have is 4. We're going to make that be a fraction, 4 over 1. So that gives us, on top here, x minus x cancels. And so we have negative 4 over x times x plus 4 divided by 4 over 1, so we can multiply by 1 over 4. The 4's cancel here because they're just 4's by themselves, and so that gives us negative, from this negative, 1 over x times x plus 4. And last, example 5. So remember, this 1 we can make be anything as long as it's the same on top and bottom. So since I have an x minus 1 here, I'd want to make the 1 be x minus 1 over x minus 1 as far as the top goes. So that we have 1 minus x minus 1 on top, the common denominator of x minus 1. And then here we need to make it x plus 1 over x plus 1. So that we have 1 plus x plus 1. You don't have to put parentheses there, technically, because it's a plus on the outside, but you can if you want to. That's x plus 1 on bottom. Let's see what we can simplify, because if we distribute this negative, we have 1 minus x plus 1. So that's going to give us 2 minus x on the top over x minus 1. Over, since we don't really need the parentheses there, we can just add, that'll be x plus 2, or 2 plus x, whichever way you want to write it. Okay, and so if we look at this, we actually are kind of stuck, which is why I hesitated, because flip up the second fraction, nothing actually is going to cancel out here because nothing's the same. This is almost the same as this, but there's a sign that's backwards, so we can't do anything. These two aren't the same, so that means our answer is simply this written together as one fraction. So that's complex rational expressions.